Hi, I'm Becky Stern. Last time I showed you how to get started with the LilyPad Arduino and how to make an LED blink. And this time I'm going to show you how to go another step further and make your whole messenger bag blink with, of course, an on and off switch. The theme of this year's Maker Faire is Remake America, so I chose to use these 12 red, white, and blue LEDs to put on my messenger bag for safety for riding my bike on my way home. Here are the things you'll need: a messenger bag or backpack with a patch or other piece of fabric, some conductive Velcro and regular Velcro, a small piece of fabric, some thread, embroidery floss, of course your LilyPad Arduino with a programmer and USB cable, and then I'm going to use this rechargeable lithium battery, which uses this LilyPad power management board, this recharger, and these wires to recharge, but you can also use the same battery power supply we used in the last project. Needle nose pliers, 12 LEDs, some conductive thread and a needle, and a pair of scissors. The idea behind this circuit is pretty simple. I split one of the pieces of conductive Velcro into two halves, and then each of these is connected to, one is connected to the power source and one is connected to the LilyPad, and when this switch comes down across these Velcro pieces, it bridges the gap, providing power to the LilyPad, which will light up a sequence of LEDs around the patch. Here's a diagram I drew out for determining where the LEDs will go. You can download a computerized version of this in the blog post with the source code. But basically, the LilyPad is here, and each of the digital pins is connected to one of the LEDs, and then the other end of the LED is connected to this ground wire that goes all the way around the outside. Prepare your LEDs for sewing by coiling the long lead in a square spiral and the short lead in a round spiral. Now stitch the ground plane all the way around the edge of the patch as pictured in the schematic, stopping to leave a gap between the two pieces of conductive Velcro and also stopping to sew the round leads, or the shorter ground leads, of the LEDs in place. Since I'm using this LilyPad lithium battery power supply and recharging circuit to go with my charger here that takes in two wires, and you can plug it into an AC adapter, I'm going to sew these two wires onto the red one onto the C pin right there, and the white one onto another ground pin over here. I'm just going to twist the leads the same way I did the LEDs. Next it's time to attach the LilyPad. I'm going to sew the positive end to the positive marking on the power supply, and I'm going to sew the negative end with the minus to this top piece of conductive Velcro that's not yet connected to anything. Now it's time to test the power circuit to make sure that it's powering the LilyPad board before we go any further, so we can correct any problems. Plug in the battery and then flip the switch on the power supply board and the little red light should come on. Nothing should happen to your LilyPad yet because this piece of Velcro is just attached to the board's ground. This piece of Velcro is attached to the power board's ground and all the ground leads of the LEDs. And so when I connect them with this other piece of Velcro, you should be able to turn the light on the LilyPad Arduino. Okay, so they're connected, and now let's see if when we press the reset button on the LilyPad board, good. That's the little blink that happens right when it boots, so we know that the board is booting okay. There's just no program on it right now to do anything else. Okay, let's talk about the code that's going to run on the Arduino. This is a pretty simple program too, but it's a little more complicated than the one we looked at last time. I based it off of a simple looping example that comes with Arduino, so you can find that up in File, Sketchbook, Examples, Digital Loop, but you can also download this code from the blog post that's altered to work with this specific circuit. So
basically I have a variable that sets the timer, that's how fast the LEDs are going to blink, and then I have this funny thing, and it's called an array, and it's going to be an array of pins. And all an array is a list. And in this case, it's a list of the pins that the LEDs are connected to. And in my case, they're in numerical order, if you fancy that. And then a variable, num pins, that's just the number of pins that I have. And then in my setup, if you remember last time, that's where we set pins as outputs or inputs based on what their function's going to be in the program. And I want to set all of the pins in the list as outputs. So I use something called a for loop, and that'll just go from 0 to whatever number here is, and I'm using num pins, which is equal to 12. And then I'm iterating by 1. So I'm going to increment this variable every time I run through this for loop, going from 0 all the way up to 11. So the 0th element is pin 1, all the way up to the 11th element is pin 12, and I'm going to set them all as outputs. And then I go down to the loop section of the code. If you'll remember, the setup function runs once, and then the loop function runs forever after that, over and over again. And in my loop function, I have another for loop, and that's going to run for as many different states that there are of the LEDs. Since I have 12 LEDs and I want to light up each alternating one, I have 6 LED states essentially, where 2 are on at one time. So I'm going to iterate from 0 all the way up to 6, which is num pins divided by 2, and then incrementing by 1. And all I'm going to do is set each LED high and then set the LED opposite from that LED high. So if I is 0, so that would be LED 1, then I'm also going to set LED 7 or 6, 7 high as well. So both of these LEDs would be on. And then the next time I will be 1, and it'll set LEDs 2 and 8 on. And then in the second part, still inside the for loop, it will turn the previous LEDs that were on off. And I have a special case here where if I is equal to 0, then it'll try to turn the -1th LED, -1st LED off. And there's no such thing as the -1st LED, so I have a special case to handle that where I tell it to go back to LED 12. But besides that, all it's doing is turning alternating LEDs on, and then the previous LEDs that were on off. And then it delays by the timer, which we set above as 100 milliseconds, and then it repeats this over and over again. So that's why you get that marquee effect where the LEDs are chasing each other. Okay, let's load it on to the chip and see how it goes.
All the LEDs power pins are sewn now to their respective pins on the LilyPad Arduino according to the schematic, and I just had to make one change that I learned. When I tested out the power, I was getting some interesting lighting effects because I was putting a switch across ground, which meant that the board had power but not a common ground with the power supply. And it was trying to find its own ground and lighting up some LEDs, so I decided to switch the power instead of the ground. So now this line that's connecting all the grounds from all the LEDs is connected to both the ground on the power supply and the ground on the LilyPad, but not the conductive Velcro tabs. Those are instead connected each to their own power, the power on the LilyPad and the power on the power supply, so that when I bridge this connection, power is connected. Now, the conductive thread has some resistance, which means that the power has trouble passing along it. So I sewed several lines across to reduce that resistance and allow electricity to flow more easily, giving it enough power. This is particularly important for the actual power supply providing electricity to the main logic board, but not necessarily as important to the LEDs, which is why they can be farther away. So now I can power up my circuit. I'm going to plug in my lithium battery, turn on the LilyPad power supply, the little red light come on, and now I'm ready to use my conductive Velcro to bridge the power switch here and turn on the LilyPad. I already programmed it using the LilyPad programmer hooked up to Arduino on my computer, and there we go, a nice light show. So it's alternating, it's lighting up every other set of LEDs around the circle. I'm going to attach it to my bag now, and I think I'll use Velcro all the way around instead of my previous idea, which was to sew part of it and then leave a pocket open to remove the battery. This way, if it rains, I can take the whole thing off, and I mean, it can get wet if there's no battery in it, but I can take the whole thing off so that I don't put these LEDs in danger when I like shove my bag around, or in case I want to get on an airplane and just don't want to deal with the hassle of having to explain it to the TSA. So I'll do that now, and then we can take it for a test ride outside.